NASA's plan to retrieve geological samples from Mars and return them to Earth is unprecedented. The mission involves collecting samples already gathered by the Perseverance rover, launching them into Mars orbit, and then ferrying them back to Earth. This process comprises multiple complex steps, each with its own set of challenges. Perseverance, which landed on Mars in February 2021, has been diligently collecting and storing samples. To complete the mission, NASA needs to build two crucial components: the Sample Retrieval Lander, SRL, and the Earth Return Orbiter, ERO. The latter is being developed in collaboration with the European Space Agency, ESA. According to a new audit report from NASA's Office of Inspector General, OIG, the MSR program faces significant design, cost, and scheduling challenges. One major hurdle is the Capture, Containment, and Return System, CCRS, which has already added $200 million to the budget and caused a year-long delay. The financial aspect of the MSR mission is a big concern. Initially estimated at $7.4 billion, costs could now soar to between $8 billion and $11 billion. Just 3 years ago, in July 2020, estimates were much lower at $2.5 to $3 billion. This steep increase is attributed to inflation, supply chain problems, and additional funding requests for specific components. Given the complexity and unprecedented nature of the mission, NASA's Inspector General has recommended several measures to address these issues. These include stabilizing the CCRS design, incorporating program complexity into cost and schedule estimates, and reassessing guidance for large missions. NASA has acknowledged these recommendations and is working on a corrective action plan. The MSR program isn't just under technical and financial pressure, it's also facing political scrutiny. With escalating costs, there's growing doubt about the program's continuation. NASA is currently re-evaluating the MSR architecture and budget, with results expected soon. Adding to the pressure, NASA is operating under a continuing resolution that freezes spending at 2023 levels until Congress agrees on the new fiscal year's budget. This has already led to layoffs at NASA's Jet Propulsion Laboratory, the main player in the MSR mission. Despite these challenges, the scientific community views the MSR mission as critically important. The samples brought back could revolutionize our understanding of Mars, its geology, and potential for past life. Meanwhile, China is not standing still. Their Tianwen-3 mission, aimed at collecting Mars samples, is set to launch by the end of this decade, adding another layer of urgency and competition. The stakes are high, and the journey is fraught with obstacles, but the potential rewards of the Mars sample return mission are immense. As NASA grapples with these challenges, the world watches, hoping for a successful mission that could unlock the secrets of the Red Planet. Let's take a closer look at the incredible achievements of the Perseverance rover, which is already making significant strides on Mars. Since landing in Jezero crater, Perseverance has been exploring the Martian surface, drilling into rocks, and collecting soil samples. Each sample is meticulously stored in special tubes that will one day be sent back to Earth. Perseverance is equipped with a suite of advanced scientific instruments designed to study the planet's geology and search for signs of ancient microbial life. One of these instruments, the Sherlock spectrometer, uses Raman and fluorescence spectroscopies to detect organic compounds and minerals. Another, the MOXIE experiment, aims to produce oxygen from Mars' carbon dioxide-rich atmosphere, a crucial step for future human missions. But collecting samples is just the beginning. The real challenge lies in safely transporting these samples back to Earth. This is where the Sample Retrieval Lander and the Earth Return Orbiter come into play. The SRL will land on Mars, retrieve the sample containers, and launch them into orbit to rendezvous with the ERO. The ERO will then ferry these samples back to Earth. The design and development of these components are fraught with technical challenges. For instance, the Capture, Containment, and Return System, CCRS, must ensure that Martian samples are securely captured and contained to prevent contamination. Any failure in this system could compromise the entire mission. To address these issues, NASA is working on refining the CCRS design, incorporating lessons learned from previous missions, and conducting rigorous testing to ensure reliability. Financial constraints are another significant hurdle. The initial cost estimate for the MSR mission has ballooned from $2.5 to $3 billion to a staggering $8 to $11 billion. This increase is due to various factors, including inflation, supply chain disruptions, and additional funding requirements for specific program components. The financial strain is further exacerbated by the continuing resolution that freezes NASA's budget at 2023 levels until Congress approves the new fiscal year's budget. This budgetary uncertainty has led to layoffs at NASA's Jet Propulsion Laboratory, JPL, the main player in the MSR mission. The reduction in workforce could potentially delay the project even further. Political pressure is also mounting, with lawmakers questioning the escalating costs and feasibility of the mission. NASA is currently reassessing the overall MSR architecture and budget, with the results expected soon. Despite these challenges, international collaboration remains a cornerstone of the MSR mission. The European Space Agency, ESA, is playing a crucial role by developing and funding the Earth Return Orbiter. Enhanced coordination between NASA and ESA is essential to address the technical and logistical challenges of the mission. The OIG report recommends improving collaboration and communication between the two agencies to ensure the mission's success. The scientific significance of the MSR mission cannot be overstated. Returning Martian samples to Earth will allow scientists to conduct detailed analyses using sophisticated laboratory instruments that cannot be sent to Mars. These analyses could provide insights into the planet's geological history, climate, and potential for past life. The samples could also help scientists better understand the potential hazards and resources available for future human missions to Mars. As NASA continues to work on the MSR mission, China is making strides with its own Mars sample return mission, Tianwen-3. Set to launch by the end of this decade, Tianwen-3 adds a competitive element to the race for Martian samples. The success of either mission could significantly advance our understanding of Mars and pave the way for future exploration. The journey to return samples from Mars is filled with challenges, but the potential rewards are immense. The MSR mission represents a monumental step in our quest to understand the red planet and our place in the universe. As NASA and its international partners work tirelessly to overcome the technical, financial, and political hurdles, the world watches with anticipation. Stay tuned to Galactic Gazette News for more updates on this groundbreaking mission and other space exploration news. Don't forget to like, subscribe, and hit the notification bell to stay informed about the latest developments in space science. Until next time, keep looking up.